Guys, this is the first of 3 videos I'm hoping for this section on stoichiometry. This should be a really short video. Some goals for this: we're going to fill out the note outline for chapter 12, part 1. So if you look at your notes, it says chapter 12, stoichiometry note outline part 1, and it has some questions there. I'm going to go through those and go through these slides with you so that we can answer those. This should take us no more than 5 minutes. And then know that I am on Zoom every Monday, Wednesday, and Friday from 1:30 until 2 to answer any questions that you have about the notes or anything in the packets. Okay, so we're in stoichiometry, which I really wish I could be there to teach you guys about stoichiometry, but that's not possible right now. So we're going to see how this works. So what exactly is stoichiometry? So stoichiometry answers the questions of how much of a substance is needed to complete a reaction or to get a certain amount of product. And I have a good definition here. It says stoichiometry is a study of quantitative, which is numbers, right? Relationships between amounts of reactants used and the products formed by a chemical reaction. So it answers the question of, if I have a certain amount of reactants, how much product can I produce? Which is kind of a question that we ask every day when we do certain tasks, especially for cooking. If we're looking at how many cookies we can make and we have 2 eggs, well, you can't make a lot of cookies, right? We have a limiting reactant or a limiting ingredient in that. So stoichiometry answers the questions of how much of something can we produce, or how much of a reactant do we need to produce a certain amount of product, right? If I want to make 100 cookies, how many eggs am I going to need? That's a question that, well, I probably don't ask every day, but a question along those lines that I ask, right? Okay. So we're going to look at mole to mass relationships. We're going to look at mole to mole relationships. We're going to look at a lot of things. So here we have an equation: iron plus oxygen yields iron 3 oxide. We can write that as a skeletal equation, right? Then this is just how rust forms. We've got iron plus oxygen yields iron 2 or iron 3 oxide, excuse me. So this is not balanced. So the next thing we do is balance it. Okay, we should know from that from chapter 10. And then what these numbers represent are the molecules, or they can represent the moles. Okay, so 4 moles of iron plus 3 moles of oxygen yields 2 moles of iron 3 oxide. Okay, we can convert that to amounts in grams. Okay, so 4 moles of iron is 223.4 grams of iron. So how did I get that? Well, I know the molar mass of iron. I multiply the molar mass of iron by 4 to get this. I know the molar mass of oxygen. I multiply the molar mass of oxygen times the moles we have, and I get this, and so on and so forth. I can do that with any equation, okay? So we have another reaction here. Okay, so I've given you some steps. Okay, hydrogen plus nitrogen yields ammonia, right? This is ammonia. We can balance it first. Okay, oops. We can express it in terms of moles. This is 1 mole. This is 3 moles, yields 2 moles. And then I can express this in terms of grams. Okay, how do we find that? We have to find the molar mass of nitrogen. The molar mass of nitrogen N2 is about 28, because I know nitrogen, the mass is about 14.0007 or something along those lines. You can look for that on your periodic table. It's N2, so it's 2 times N. That gives us about 28, so it should be about 28 if I'm right. Yep. Okay. We can find hydrogen the same way. We can find ammonia the same way. Ammonia, excuse me. Okay, now how does this help us to figure anything out? Well, honestly, this bottom part is just a exercise in finding molar mass that we do not need right now. The important part is this right here, our moles, finding out how many moles we have so we can make what we call a mole ratio. And here are some examples. If you want to do more of what we just did here, you can do some more of these examples, and I will upload a key to this at some point. So what is a mole ratio? Well, a mole ratio is just a ratio between the number of moles of any 2 substances in a balanced equation. So if we're looking at this equation, we can come up with a lot of mole ratios. Okay, for instance, for every 4 moles of iron we have 3 moles of oxygen. That's our mole ratio. Okay, We can do that backwards as well. For every 3 moles of oxygen we have 4 moles of iron, okay? I can do that with every single reactant and product in this equation with this, and I think that's in your notes on page 6, okay? Now, why would we want to do this? Well, we want to be able to convert to different moles of substances so that we can convert to different masses of substances, okay? That should answer you all the way to number 4 on the note outline. And number 5, number 5 asks us to balance these reactions and then come up with the mole ratios, okay? So I'm going to let you do that, and I'll upload the key to that, okay? If you have any questions, you can catch me on Zoom, Facebook message me, whatever you want to do, and I will try and answer those questions for you.